Alright guys, welcome to the graphing absolute value inequalities video. We are going to graph these things much like we did in the other videos. If you have not watched the linear one or the quadratic one yet, I do a lot more explaining in that one than I will in here. I'm going to go fast, get this one down to maybe like 5 minutes because the bell's going to ring in 5 minutes. So, to graph this inequality, y is less than absolute value of x minus 3, you have to first know how to graph y equals absolute value of x minus 3. So sticking with the transformations, this goes to the right 3, so that vertex will be at 3, 0. And then with absolute value, it's just that V shape, where if I go right 1, I go up 1, right 2, up 2, and they have a constant slope both directions. But that same idea of do I fill in the line dotted or solid? So remember, if there's no or equal to, then we don't want to include the points on the line in our solutions, and that's why we do a dotted line, because the line is where they're equal, and we don't have an or equal to. So dotted line, when I do these problems with the or equal to, I'll do solid. I'll do dotted on this one. And then comes shade above or below. So I tell kids, hey, it's y is less than. Go put your finger on the graph or your pen, and where the y is less? Down below. And so you shade below. So again, if it's a less than, or less than or equal to, you shade below, as in these 3 examples. With this one, when I get here, I'll shade above. Also remember, you can take any point in the solution area, so in the shade area like 0, 0, and you can plug that in to your inequality. So if I plug in 0 and 0, then I get 0 is less than absolute value of negative 3. Absolute value of negative 3 is 3, and that is true. So I must have shaded correct, so you can check your work. So over here, this one goes down 3, which is where your vertex will be, and it reflects across the x-axis. So now it's going to go down, and it doesn't stretch or shrink, so that over 1, down 1, over 2, down 2 is still the same. It's got an or equal to, so I will follow those lines with a solid line. And then it's y is less than. So I go on the graph and I shade below. Alright, next one. This graph goes right 4, down 2. Again, the left, right, up, down will control your vertex. So it's at 4, negative 2. And this one vertically stretched by 3. No reflection, so I still go up. But now, rather than over 1, up 1, it's still over 1, but that vertical distance of 1 is going to get stretched to a distance of 3. Also, if I go over 2, normally it's up 2 from the vertex. Now it's going to be over 2 and up 3 times 2, which is 6. And so that kind of affects the slope and the steepness of the graph. Since it's got an or equal to, I will use a solid line here. And when it's y is less, the y's are less down low. And so I shade below. Some of you shade like that. Alright, and then on number 4, I go right 1. Whoop, whoop. There's my vertex. And then now it's a vertical stretch by 2. So rather than over 1, up 1, it's over 1, up 2 now. So that distance got multiplied by 2. Rather than over 2, up 2, it's over 2, up 4. So you're vertically multiplying those by 2. Now, this is no or equal to, so it's going to be a dotted line. Those are so fun to do. Woohoo! Alright, and then it's y is greater, and so I'm going to shade above, which would put me inside of this V. Alright, so you artistic people can get real fancy with your shading. I just do this to get the point across. Alright, again, I lay out and write some notes about the shade above, below, a lot more in the other videos. So if you want to go watch those, there's a little short, quick, 5-minute video on graphing absolute value inequalities. Adios, papas fritas.